Today's video is on recurrence relations. So now I am going to discuss what is a second order homogeneous recurrence relation. So an equation of the form an is equal to c1 an minus 1 plus c2 an minus 2 where n greater than or equal to 0 is called the second order homogeneous recurrence relation. So here if you want to find the order of this, so order of this is nothing but the difference between the greatest subscript minus the lowest subscript. So among these the greatest subscript is n and the lowest subscript is n minus 2. So if I make a difference, that is n minus of this is n minus 2, then this will be n minus n plus 2. So the order is 2. So this is the second order homogeneous recurrence relation. So how to find the characteristic equation? So here the order, the highest order is 2. So here this is r square. So if I bring this term to other side, this will be minus. This is minus c1r. If I bring this to other side, this will be minus c2. This is minus c2 is equal to 0. So this is the characteristic equation. And if we solve, we'll be getting two roots, that is r1 as well as r2, and these are the roots and these are the solutions. See here, if the roots are real and distinct, different real roots, if we get example 2, 3, so the solution will be an is equal to alpha 1 r1 power n plus alpha 2 r2 power n. r1 and r2 are nothing but the roots here. So for example, if we take 2, 3, then the solution will be an is equal to alpha 1, this is 2 power n plus alpha 2 into 3 power n. So if the roots are real and equal, so if we get a real roots, for example 2, 2, so what is the solution for this? So an is equal to alpha 1 plus n times of alpha 2 into r power n. So here the root here is, the equal root here is 2. So this can be written as an is equal to alpha 1 plus n alpha 2 into 2 power n. And if we get the third case as complex roots, that is 2 plus or minus 3i. So this can be written as, the solution is given as an is equal to, this is r power n into alpha 1 cos n theta plus alpha 2 sin n theta. So how will be getting alpha r? So r is nothing but root over alpha 1 square plus alpha 2 square. So if we consider this one as alpha 1 and alpha 2, so our root r value will be root over 2 square plus 3 square, and theta value is nothing but tan inverse of alpha 2 by alpha 1. So we'll be getting r value and theta value. If we substitute in this equation, so we'll be getting the solution for the complex roots. So here this is the second order homogeneous equation. So this is the characteristic equation. So after finding the roots, so these are the three cases. One is real and distinct, next one is real and equal, next one is complex roots. I'll be giving one example for each model. So first one is, so find the recurrence relation for an plus 1 minus 3 times of an plus 1 plus an is equal to 0 with the conditions a0 is equal to 1 and a1 is equal to 0. So let's get started. So for the solution, the given recurrence relation is given. See here, the recurrence relation is an plus 1 minus 3 times of an plus 1 plus 2 times of an is equal to 0. Now the characteristic equation will be, see here, the characteristic equation is, so for this r square minus 3 into r plus 2 is equal to 0. So if I find the roots for this, so this will be r square minus 2r minus r plus 2 is equal to 0. So if I take r common, this will be r minus 2. Again, if I take minus common, this will be r minus 2 is equal to 0. So if I take r minus 2 common, so this will be r minus 1 is equal to 0. So I got the roots as 1, 2. And after getting these roots, what we have to do? So we have to find out the solution. Therefore the solution, that is an is equal to, so how we have to write? One constant, that is 1 power n, second constant, that is 2 power n. So this is an is equal to C1 1 power n plus C2 2 power n. So here we have certain conditions here. So A0 is equal to 1 is given and A1 is equal to 0 is given. So first one, A0 is equal to 1. So how we'll get A0? If we put n is equal to 0, we'll be getting A0. So A0 is equal to C1 1 power 0 plus C2, this is 2 power 0. So what is A0 here? A0 is 1. It is given in the question. So 1 is equal to C1. Anything to the power of 0 is 1, and this is the C2, and this will be, see here, this is equation number 1. And the next one, the next condition here is, see here, A1 is equal to, see here, A1 is equal to 0. So we have another condition, that is A1 as 0. So if we put n is equal to 0 in this equation, so A1 value is equal to, A1 value is equal to C1 1 power 1 plus the C2, this is 2 power 1. So what is A1 here? This is 0. So this will be C1 plus 2C2. This is C1 plus 2C2. See here. So there is a small correction here. So this is nothing but 6. So this is not 0, this is 6. So if I keep 6 here, then the second equation will be C1 plus 2C2 value is equal to 6. So on solving 1 and 2 equations, so on solving, see here, on solving 1 and 2 equations. So if I solve these 1 and 2 equations, see here, this is a C1 plus C2 is equal to 1, and here this is a C1 plus a 2C2 is equal to 6. So this is equation 1 and this is equation 2. So if I multiply equation 1 with 2 and then subtract, then see what happens. If I multiply with 2, this is a 2C1 plus 2C2 is equal to 2, and this is a C1 plus 2C2 is equal to 6. So if I subtract these equations, then see what happens. Then this will be C1. So if I cancel this one, this is minus 4. So we got the value of C1. So here I got the value of C1 as minus 4. Now if I substitute the C1 value in equation 1, substitute C1 value in equation 1, that is C1 plus C2 is equal to 1. What is C1 here? Minus 4 plus C2 is equal to 1. C2 is equal to 1 plus 4, and C2 we got as 5. So we got the value of C1 and C2. Now what is the solution here? An is equal to, see here, An is equal to C1 1 power 1, that is a C2, this is 2 power n. So in this, if I keep the values of C1 as well as C2, then this will be, see here, An value will be, so what is our An? C1 is nothing but minus 4, this is 1 power n, and what is C2? This is 5, this is 2 power n. So this is the solution here. So this is the solution. See here, we have to find the recurrence relation. For that, first we have to write the characteristic equation, and after finding the roots, see here, this will be the solution of case 1. So this is of case 1. So we have certain conditions that A0 is equal to 1 and A1 is equal to 6. So after getting these two equations, so now we have to solve for finding the values of C1 as well as C2. And after getting C1 and C2, so this is the solution for the given recurrence relation. So here this is of type case 1. So the next one, so for case 2, so if you find this one, we have to solve the recurrence relation. So we have to solve for the recurrence relation given An minus 6 times of An minus 1 plus 9 times of An minus 2 is equal to 0, where the conditions are A0 is equal to 5 and A1 is equal to 12. See here, first of all, given recurrence relation is given the given recurrence relation is An minus 6 times of An minus 1 plus 9 times of An minus 2 is equal to 0. So first of all, we need the characteristic equation. See here, the characteristic equation is, so for this, the characteristic equation will be, see, this will be r square minus 6r plus this one is 9 is equal to 0. Now we have to solve for this. So this can be written as a square minus 2 into A into B plus this is B square is equal to 0. So this can be written as R minus 3 whole square is equal to 0. So I am getting the equal roots, the case 2, that is 3, 3. So the solution will be, see here, this, therefore the solution is, the solution an is equal, can be written as, this is a C1 plus a C2n. So C1 plus a C2n into this is 3 power n. So this is the solution. So now we have certain conditions here, that is A0 is equal to 5 and A1 is equal to 12. First we have A0 is equal to 5. So how will be getting A0 when we put n is equal to 0? So n is equal to 0 in this equation, if we keep A0 value will be C1 plus C2 into 0 into this is 3 power 0. So A0 value is equal to C1. So this is already 0, this is 1. So we got A0. So therefore C1 value, what is A0 here? This is 5. So we got the value of C1 as 5. And the next one here is A1 is equal to 12. So we have A1. So A1 is equal to 12. So we have to put n is equal to 1. So for that A1 is equal to, this is a C1 plus a C2. N is equal to 1. This is 3 power 1. So what is A1 value? A1 is equal to 12 here. This is 12 is equal to C1 is 5 plus C2 and this is 3. So this is 12 is equal to 5 3s are 15 plus 3C2. So this is 12 minus 15 is equal to 3C2. This is minus 3 is equal to 3C2 and C2 is equal to minus 3 by 3. C2 is equal to minus 1. So we got the value of C1 as well as C2. So this is C1 and C2. Therefore the solution is, see here, the solution an is equal to, see I'll show you, C1 plus C2n, as they are equal roots, C1 plus C2n into this is 3 power n. So this is 3 power n. Now I'll substitute all the values here. That is, what is C1 here? C1 is 5 times, and what is C2? So this is minus 1 into n into this is 3 power n. So this can be written as, this is 5 minus n. 5 minus n into this is 3 power n. So this is of case 2. Case 2, if we get equal roots, so we have to find the solution like this. So first of all, the given recurrence relation is given and the characteristic equation. So this is r square minus 6r plus 9 from this equation. So after finding the roots, we got equal roots, different root. No, these are real and equal roots. So for that case 2, we have to write in this combination, that is C1 plus C2n into 3 power n. So we have certain condition as A0 is equal to 5 and A1 is equal to 12. So if you substitute all these equations, we'll be getting the C value as 5 and C2 as minus 1. So if I substitute the solution here, for the given recurrence relation is 5 minus n times of 3 power n. And now coming to case 3, so those are complex roots. So here for complex roots we have to solve, that is solve the recurrence relation an minus 2 times of an minus 1 minus an minus 2 is equal to 0, n greater than or equal to 0, a0 is equal to 1 and a1 is equal to 0. See here, the given recurrence relation is, the given recurrence relation is an minus 2 times of an minus 1, this is minus into minus, plus 2 times of an minus 2 is equal to 0. Now we have to frame the characteristic equation. See, the characteristic equation will be, so this is nothing but r square minus this is 2r plus 2 is equal to 0. So how to find the roots for it? For this, so this is, for r value we have minus b plus or minus root over b square minus 4ac by 2a. So here our a value is 1, so a value is 1. So what is the b value? This is minus 2. C value is equal to plus 2. If I substitute in this formula, r is equal to minus b. So what is b here? Minus 2 plus or minus root over b square. So this is minus 2 whole square minus 4 times of a value is 1, c value is 2 by that is 2 into 1, 2a. So r is equal to 2 plus or minus, this is 4 minus 8 by 2. So r value is equal to 2 plus or minus, this is minus 4 divided by 2. R is equal to 2 plus or minus, this is 2i by 2, and r is equal to 1 plus or minus i. So this is the value we got. So this is a complex root. See here. So we got complex roots. So how to write the solution for this? See here. Therefore, the solution is equal to, the solution we have to write as an is equal to, this is r power n. So this is r power n, c1 cos n theta plus c2 sin n theta. See here, c1 cos n theta. So how we'll get r? R value is equal to root over. So if you consider this as p plus or minus qi, so this will be p square plus q square. So r value is equal to, what is p here? 1. So this is 1 square plus 1 square. R is equal to, this is root 2. And how about this theta? Theta is equal to, this is tan inverse of q by p. So this value is q by p. Theta is equal to, this is tan inverse of, so this will be q is 1 and p is 1. Theta is equal to, this is tan inverse of 1. So when we'll get 1 in tan theta, so this is 45 degrees, pi by 4. So we got r value as root 2 and theta value as pi by 4. Therefore, the solution an is equal to r power n. This is c1 cos n theta plus c2 sin n theta. So if I substitute all the values, then our an value is equal to r, that is root 2 power n c1 cos n into pi by 4 plus c2, this is sine times of n into this is pi by 4. And after getting the solution, we have initial conditions as a0 is equal to 1 and a1 is equal to 2. So we have a0 is equal to 1 and a1. So this is a1 is equal to 2. Now we have to substitute those. So if I keep on substituting, so how we'll get a0? If we put n is equal to 0 in this given equation. See here, if I put n is equal to 0, this is a0 is equal to, this is root 2 power n, this is c1 cos, in place of n if I keep 0, so this will be 0, sine, if I keep n is equal to 0, this will be 0. See here, a0 value is, so in place of n we have to keep 0. So anything to the power of 0 is 1. This is c1 cos 0 is 1 and c2 this is 0. What is a0 here? So a0 value is nothing but 1. So if I keep 1 here, this will be only c1. So we got the value of c1 is equal to 1. So after getting c1 value, now the next condition here is a1 is equal to 2. So we have a1 is equal to 2. So now see here, if I put n is equal to 1 in the equation, in the solution here. So here the solution is, so if you see the solution, an is equal to, so in this if I keep n is equal to 1, so a1 is equal to root 2 power 1. This is c1 cos, this is pi by 4 plus c2 sin n. So this value is pi by 4 and see what happens here. So this will be, so this value will be a1 is equal to, so this is root 2 and this is cos 45. So this is 1 by root 2 and this is again 1 by root 2. So if I take common and cancel, what is a1? a1 is equal to 2. So 2 is equal to, this is root 2 times of, this is a c1 plus a c2 by root 2. Now if I cancel this root 2, then see, c1 c2 value will be, so c1 plus a c2 value is equal to 2. So what is c1 from this? c1 is equal to 1. Since c1 is equal to 1, so 1 plus c2 is equal to 2, c2 is equal to 2 minus 1 and c2 value is 1. So we got c1 as well as c2. See here, we got c1 1 and again c2 1. So what is the solution here? an is equal to root 2 power n. This is c1 cos, this is n pi by 4 plus c2 sin, this is n pi by 4. So if I substitute c1 as 1 and c2 as 2, then this will be the general solution. So an value is equal to root 2 power n. This is c1. So in place of C1 we have to write 1 here. So this value is 1 times of, this is cos n pi by 4 plus what is C2? C2 is again 1. So this value is also 1. That is 1 times of sine n pi by 4. And see here the solution I am writing once again. So an value is equal to root 2 power n. C1 is 1 cos n pi by 4 plus C2 is 1. This is sine n pi by 4. And this is the general solution. This is how we have to solve. These are all the 3 cases, and in from these 3 cases you can solve many more problems by your own choice. And thank you so much for watching, and I'll be uploading many more solutions for the second order recurrence relations, and keep watching. And then my upcoming video is on third order recurrence relation. Have a look at those and it will be immensely helpful for your preparation. Please pass it on if you really like, and subscribe to this channel.